All right, this is the video for the review for test quadrilaterals, Unit 11. Have your packet out so you can follow along as we go through the video. Number 1, place each of the polygons listed below in the appropriate place in the Venn diagram at the right. Use each polygon exactly once. So we have our overarching circle and 2 littler circles. We know the entire thing we're talking about are quadrilaterals. Our quadrilaterals, we can break them down into 2 subsets depending on how many pairs of opposite sides we have parallel. If we have only 1 pair of opposite sides parallel, we have a trapezoid. In addition to our regular trapezoids, we also discussed isosceles trapezoids. If we had 2 pairs of opposite sides parallel, we have a parallelogram. Our parallelograms can be broken down into are our sides congruent or are our angles congruent. If all of your angles are congruent, you have a rectangle. If all of our sides are congruent, we have a rhombus. Now the overlap has both sides congruent and all of our angles are congruent, and that's our square. So there's our quadrilaterals Venn diagram. Number 2, it says using the diagram at the right, you're trying to solve for x in trapezoid UVWX. Which of the properties below should you use? Circle only one. Well, with opposite angles, with a trapezoid, we don't know anything about our opposite angles. They don't necessarily have to be congruent, but they also don't have to add to 180. Our consecutive angles are not congruent because we have the parallel lines, which means our consecutive angles are going to add up to 180 degrees. For part B, you can use either set of consecutive angles. We have the 10x plus 8, and since we know that those have to add to 180, one potential thing we could do is we could say 10x plus 8 plus 8x plus 10 equals 180. So 10x plus 8 plus 8x plus 10 equals 180. We also could have used the other pair of consecutive angles. So we could have said 13x plus 20 plus 5x minus 2 equals 180. Could have also had used either pair of consecutive angles. We don't need to solve this. All we have to do is set it up. So once we get here, we're good. Move on to the next page. We have some questions about properties of the rectangle. We want to circle all the properties that apply to rectangles. With rectangles, we know they have all the properties of parallelograms, and they have those 2 additional properties. If we had all sides are congruent, that's not a rectangle, that would be a rhombus. Opposite sides are congruent is a property of parallelograms, so it's also true for rectangles. Diagonals bisect each other is a property of parallelograms, so it's also of rectangles. Our other properties of parallelograms that also apply to rectangles, opposite angles are congruent, consecutive angles are supplementary. Then we have those 2 additional properties that make something specifically a rectangle, and that is that all angles are congruent and our diagonals are congruent. So those are all the boxes you should have circled. Question 4 is asking you about diagonals of a rhombus. Well, since a rhombus is a parallelogram, we know our diagonals bisect each other. And we had 2 special properties that made something a rhombus that dealt with diagonals. And that was that our diagonals are perpendicular and that our diagonals bisect opposite angles. The last one says diagonals are congruent or diagonals are not congruent. In a rhombus, they are not congruent. In the rectangle, they would be congruent. Question 5 is checking if do you know what all 4 angles in a quadrilateral have to add up to? Thinking back to when we did angles and polygons, we know that a 4-sided figure, all our angles have to add to 360 degrees. So what we want to do for this problem is take 360 minus the other 3 angles. So when we add 157 plus 89 plus 71, and then subtract that from 360, we get that x is 43 degrees. Number 6, we're jumping into parallelogram solving problems with parallelograms. So I want to use my properties. In A, the property I want to use is that my diagonals bisect each other. So then I know that those 2 pieces are equal to each other. So to find x, I have to set 10 equal to 2x minus 4. So I solve this, I add 4. And then divide by 2. So I get x 7. For the second problem, I have consecutive angles. Well, I know consecutive angles have to add to 180. So I can say that x plus 9 plus x minus 9 is going to equal 180 degrees. So when I combine my like terms, I get 2x equals 180 because 9 minus 9 cancel out. Divide by 2. So for B, x is 90. And on C, we have opposite angles. Well, opposite angles are congruent, so I can set 3x plus 10 equal to 5x minus 30. I need to bring all my x's over to one side, so I subtract the 3x. Add the 30. Divide by 2. So x is 20. So there's number 6. Number 7, using the parallelogram at the right, find the values of x and y. For this one, I want to use that my opposite sides are congruent. So I know that 30x is going to equal 150, and that 2y is going to equal 72x. I'm going to solve for x first because I have this expression here that says 30x equals 150. So I only have one variable. I just divide by 30, and I get that x equals 5. So then I can come over here to find y, and to find y, I plug 5 into x. So 2y is 360, divide by 2, y is 180. All right, continue on. Number 8. Number 8, it says in rectangle A, B, C, D. So I draw my rectangle out. I know AB is 6x plus 5. CD is 35. And BC is 2x plus 10. So I want to solve for x and then find BC. So in order to solve for x, I need to use my opposite sides are congruent again. So I know that 6x plus 5 equals 35, so I subtract the 5. And then divide by 6. So I get x equals 5, but I'm not done yet. I have to find BC. So I take the fact that BC was 2x plus 10, and I plug 5 in for x. So BC is 20. Number 9. In rectangle RSTQ, RB, is 5x minus 13. SQ, so this entire diagonal here, is 4x minus 2. All right, so we have half a piece of the diagonal and then a full piece of the diagonal. We have two options here. One option is we know that since RB is 5x minus 13, DT is also 5x minus 13. So I can say that RT is 2 times 5x minus 13. And RT is going to equal SQ because in a rectangle, our diagonals are congruent. So I can say that 10x minus 26 equals 4x minus 2. Subtract the 4x. Add the 26. Divide by 6, I get x is 4. Then I have to find the length of the diagonal. So I'm going to take my length of my diagonal, which I can use either the 4x minus 2 or the 10x minus 26, and plug it in. Look at my diagonal has a length of 14. Number 10. In parallelogram to the right, find the value of each numbered angle. Well, I'm going to start with number 3 and 4. For 3 and 4, I know it makes a line with my 52-degree angle. So for angle 3 and 4 is 180 minus 52, which is 128. I know 3 and 4 are congruent because they're vertical angles. Okay. So now, since I have a rectangle, since number 10, this parallelogram is specifically a rectangle, because since I have one right angle, I have all 4 right angles. So I know my diagonals are congruent, because I know all these pieces are congruent. Since I know the pieces are congruent, I can look at this little triangle here to help me find angle 2. Because angle 2 is going to be congruent to angle 6 since I have an isosceles triangle. So to get angle 2, I can do 180 minus 52, which is again the 128, and divide that by 2. Since I have to, 128 has to go to angle 2 and 6, and since they're congruent, I get they're both 64 degrees. For angle 1, I can do 90 minus 64 because it makes a right angle with angle 2. Oops, this is number 1, not number 7. So I know angle 1 is 26 degrees. Angle 5. If I look at my parallel sides, I know angle 2 and angle 5 are alternate interior angles. So angle 5 is also 64 degrees. And angle 7 is asking us for the entirety of angle P. Well, since I have one right angle, I have 4 right angles. Angle 7 has to be 90 degrees. Number 11 is asking you about slopes. In rectangle ABCD, the slope of AC is negative 3/7, and the slope of AB is 6/5. So find the slope of BC. I know that AB and BC are perpendicular since it's a rectangle. Well, perpendicular lines have opposite reciprocal slopes, so my slope of BC is the opposite reciprocal of 6/5. So that's negative 6/5. DC, I know DC is parallel to AB, so they have the same slope. AD is parallel to BC, so I know AD and BC have the same slope, which means that C is negative 5/6. So there's all of our slope questions. Number 12, I have a rectangle, which means I know I have 4 right angles. I know my opposite sides are congruent, so I know this side over here is also 24. So if I look at this triangle here, I have a right triangle. Trying to find one of my sides, I have 2 of the lengths, so I can use Pythagorean theorem. I know that 87 squared is going to equal 24 squared plus x squared. 87 squared is 7,569. 24 squared is 576. Squared, subtract the 576. Okay, 6,993 equals x squared. Square root both pieces. And I get that x is 83.624 inches. So there's number 12. We'll move on to the next page. Number 13. The figure below represents the side view of a rectangular frame from metal shelves. The 2 diagonal braces support the frames. Find the measure of x. So we're walking you through this one. So for number 13, we know that we have all these right angles. So to find angle y, I want to look at this triangle right here. I'm going to draw off to the side to make it a little less confusing. I'm looking for an angle measure, and I have a right triangle. So I know I can use trig, because I know that y is going to equal, that the tangent of y is 13 over 5. So y is going to equal the tangent inverse of 13 over 5. And the tangent inverse of 13 over 5 gives me 69 point, no wait, it's not 69, sorry. Okay, tangent inverse of 13 over 5 is 68.962 degrees. So this angle right here is 68.962. So then I'm looking for the measure of DBA, this angle here. Well, since I know these pieces are congruent, angle DBA is also 68.962. Now I'm just looking at this little triangle here. So now I have 2 of my angles. I have my base angles. So what I want to do is I want to figure out what's left over for x. So it'd be 180 minus 2 times 68.962. And I get x is 42.076 degrees. So let's look at number 14. 14 is actually the same type of problem. We're just not walking you through it, but do the same steps. You know, we have this triangle here. I'm going to again draw out for the ease of looking at stuff. X is, we're going to eventually want to look at this little mini triangle. So I want to find that angle BDC. I'm looking for that angle right here, which I'm going to call y, just for the sake of making it look like the problem above. So I know that y equals the tangent inverse of 12 over 4. So y is 71.565. So I know that my base angles are both 71.565. So if I multiply that by 2, I know my base angles add up to 143.130, and subtract that from 180. I get that x equals 36.87 degrees. 15 is again the same type of problem. So again, I want to look at my right triangle. Since x is in this little mini triangle, I want to find BDA first. So I draw out my little triangle, 3, 11, y. Y is going to equal the tangent inverse of 3 over 11, which is 15.255. Multiply that by 2 because I know EAD is also that 15.255. So my base angles add up to 30.510. Subtract from 180. And I get that x is 149.490. All right. Number 16, we're moving away from rectangles for right now. Okay. Given ABCD is a rhombus with length of BD equals 12. So I know this whole thing is 12, so this has to be 6, and this has to be 6. Since the rhombus, I know that my diagonals are perpendicular. So if I look at this little mini triangle here, I'm looking for AD. Well, I want to use trig. I'm looking for a side. My 6 is my adjacent. My x is my hypotenuse. So I know that the cosine of 40 is 6 over x. Cross multiply, set it up as a proportion. X cosine 40 equals 6. Divide by the cosine of 40. So x is 6 over cosine 40. So x equals 7.832. Number 33. Given ABCD is a rectangle, find the length of BD. So we're looking for this piece here. I know my diagonals are congruent and my opposite sides are congruent. So this is 5 and this is 30. So I'm going to use this triangle here to find BD. Well, you can either use trig or you can use your 30, 60, 90. I'm going to use 30, 60, 90 just because we just did trig in number 16. So we have our 30, our 60, and our 90. The 5 is, so our inside goes 1 square root 3, 2. Across from the 30 is the 5. We're looking for the side across from the 90. So 1 over 5 is 2 over x. So I get x equals 10. Number 18. Rhombus A, B, C, D, and the given information to find each measure. So if I look at all my given information. Okay. DAE. Looking for this angle right there in blue. Well, I know at angle E, since the rhombus, that's a 90-degree angle. So if I look for DAE, I know this is a right triangle. So to find DAE, I do 90 minus 28 and get that DAE is 62 degrees. For BD, I'm looking for this whole length here. Since a rhombus is a parallelogram, I know my diagonals bisect each other. So since DE is 15 and BE is congruent to DE, BE is also 15. So 15 plus 15 makes BD 30 inches. C, a measure of DBC. Well, it's opposite. It's an alternate interior with 28. So DBC must be 28 degrees. All right. AB. Well, it's a rhombus and all of our sides are congruent. So AB is 17. Then we get to AE. You have a right triangle here. I'm going to draw right here to see what we're looking at. We have this part's 15, that's 17, and that's a right angle, and we're looking for x. So we do Pythagorean theorem. 17 squared equals x squared plus 15 squared. So we get that AE is 8. Number 19. Use rhombus A, B, C, D to answer the following questions. Angle 1. Angle 1 is right here where our diagonals intersect each other. So since it's a rhombus, we know that our diagonals are perpendicular, so angle 1 is 90 degrees. The slope of AC is 4/5. What's the slope of BD? Since AC and BD are perpendicular, BD has to have an opposite reciprocal slope, so the slope of BD is -5/4. For letter C, it says the measure of angle 3 is 5x plus 4. The measure of angle 4 is 4x plus 20. We know our diagonals bisect opposite angles. So since angle BCD got bisected by our diagonal, I know that angle 3 and angle 4 are equal to each other. So 5x plus 4 equals 4x plus 20. Solve this, subtract the 4x. Subtract the 4. I know that x equals 16. So then, for angle 3, I'm just going to come plug it in. 5 times 16 plus 4 makes angle 3 84 degrees. Or angle 3 84 degrees. Since angle 4 is congruent to that, angle 4 is also 84 degrees. Angle 5, well, we know that this is a right triangle. So 84, 90 minus 84 has to give us angle 5. All right. No, hold on. Okay, so we know that this little piece here is 6. So this part here is 6 also, so angle 5 is 12. Angle 6 is also 12 because opposite angles are congruent. And then angle 2, angle A is congruent to angle C, so we know angle 2 is congruent to angle 3 and 4. So angle 2 is 84 degrees. All right, number 20. Use the rhombus below, solve for x. Okay, x and angle, we know that part there is 24. AD has to be 25. So we can use trig. X would be the cosine inverse of 24 over 25. Which means x equals 16.260 degrees. Okay, for number 21, find the value of x in the square below. We know those two pieces are congruent, and that's a right angle. That's also 9, so find x. 9 squared plus 9 squared equals x squared. So x is the square root of 162. X is also, since it's 45, 45, 90. So thanks. 9 radical 2. All right, so we go to the next page. We have, if A, B, C, D is a rhombus, AE equals 6, BD is 16, and ABD is 67. We want to find the length. We know this entire thing is 16. So we can find the length of BE. Well, since a rhombus is a parallelogram, then we know that BE is half of BD, so BE is 8. So let's put that on there instead of that confusingness. The measure of AED, well, since it's a rhombus, we know our diagonals are perpendicular, so that's 90 degrees. BCE, so since we know that ABE is 67 degrees, DBC is also 67 degrees, so we can do 90 minus 67, which is 23 degrees. And then for DC, using this right triangle here, I know that EC is 6, so to find DC, I can do 6 squared plus 8 squared equals DC squared. So DC is 10. Since it's a rhombus, we know all of our sides are congruent, so BC is 10, BA is 10, and AD is 10, which makes our perimeter 40. 23. DEFG is a rhombus. DM is 5x minus 1. MF is 2x plus 5. And GE is 24. Since GE is 24, I know GM is 12 and EM is 12. So to find, to find X, I know that DM and MF are congruent, so I set 5x minus 1 equal to 2x plus 5. So I get 3x equals 6, so x is 2. To find FM, I plug 2 in for x. So 2 plus 2, 2 times 2 plus 5, FM is 9. So I'm going to erase these and put that DM and MF are both 9. EMF is 90 degrees since it's a rhombus. Our diagonals are perpendicular. So for MGF, we're going to have to use some trig. We know that that piece is 9, so we're looking for this angle. So MGF is going to be the tangent inverse of 9 over 12, which is 36.869. All right, so then DG. To get DG, we have to use Pythagorean theorem. 9 squared plus 12 squared makes DG 15. So since DG is 15, all of the sides are 15. That means our perimeter is 60. Going to squares. Number 24, measure of angle P. Well, I know since it's a square, it has all the properties of parallelograms, rectangles, and rhombi. So that means that P3P is going to equal 90 degrees. So P is 30. Since all of these are 90, and all of our main angles of our squares are 90, but our diagonals of a rhombus bisect the opposite angles, R has to be 45, and 5T has to also equal 45. So R is 45, and then 5T equals 45. So T is 9. So there's everything with our angles. For B, the values of x and y, if BF is 4x minus 2, AF is 3y minus 3, FC is 3x. I know all of these little pieces are congruent. So to find x, I'm going to take BF and FC. So I get negative 2 equals negative x. So x is 2. So then, I can use that my diagonals bisect each other, plug in 2 into the 3x. So I know each of these pieces are 6. So 3y minus 3 has to equal 6. So 3y equals 9, which makes y equal to 3. 25, it says find the missing angles in the trapezoid below. Since we have our congruent sides, we have an isosceles trapezoid, which means our base angles are congruent. So A is congruent to B, and C is congruent to D. So B, I know, has to be 126 degrees. And then I also know, since we have parallel lines, our consecutive angles are supplementary. So to get C and D, I do 180 minus 126, which means C and D are both 54 degrees. 26, find the missing angles in the trapezoid below. This one is not a isosceles trapezoid. So all we know is that our consecutive angles add to 180. So to find C, I do 180 minus 112. And I get that C is 68. And to get B, I do 180 minus 61 to get that B is 119. 27, we have A, B, C, D as an isosceles trapezoid. All right, so AD is our diagonal. And AD is 3x plus 6, and BC is 7x minus 10. In our isosceles trapezoid, our diagonals are congruent. So to get x, we do 3x plus 6 equals 7x minus 10. So we know 4x equals 16, so x is 4. And to find AD and BC, we go and plug it in for x. 3 times 4 plus 6 makes AD 18, and since BC is congruent, BC is also 18. 28. 28 is an isosceles trapezoid, which means our bases our legs are congruent, so x is 12. All right, and then we get into our coordinates. DEAN is a square centered about the origin. We need to find the coordinates of E, A, and N. So since it's a square, everything's going to have the same length. And since this piece is 4, and this piece is 4, everything's going to be 4. So remember what's positive where. E is going to be the 0.44. A is in quadrant 4, so my x is positive, my y is negative, and N, everything's negative because we went down. Gram is a parallelogram centered about the origin. Find the coordinates of M. So I know that this distance here is negative A. This distance here is B. This distance here is C. This distance here is B. This distance is A. This is B. So since it's a straight line, we know our y coordinate is going to be the same as our y coordinate from A, so it's negative B. And then for our x coordinate, since we know our opposite sides are congruent, C plus negative A has to equal A plus something. So I want to figure out, I'm going to get this by itself, so I subtract the A. Your answer should be negative C. All right. 31, A, B, C, D is a rhombus. Find the coordinates of C and D, and this time we have actual numbers. So we know D is 8, so if we drop our perpendicular to see the distances, this little distance is 8. We don't know this horizontal or the vertical distance. We know OAB is 17, which means everything has to be 17. All of our sides are 17. So to find the x value for C, we know we have to go over 17 units from 8, so do 17 plus 8. To find the y value, we have to do some Pythagorean theorem using this triangle here. So 17 squared equals 8 squared plus x squared, which makes x 15. So our x value for C is 15. Our x value for D is also going to be 15. And our y value for B is going to be the same as our y value for A, so B is the 0.170. Next page. Based on the points, describe how you could use slope, distance, or midpoint to prove what shape it is. So how could slope be used? Slope is going to tell you which lines, if any, are parallel or perpendicular. Because if you have two pairs of the same slope, you have a parallelogram. If you have one pair of the same slope of the sides, you have a trapezoid. If your diagonals have opposite reciprocal slopes, you know your diagonals are perpendicular then, so then you have a rhombus. And if you have sides that have opposite reciprocal slopes, you have either a rectangle or a square. You have a rectangle. Distance is going to show you what's congruent. If you have two pairs of opposite sides congruent, you have a parallelogram. If you have diagonals congruent, you have a rectangle. If all sides are congruent, you have a rhombus. For C, how could midpoint be used? Midpoint's only going to tell you something about your parallelograms, because the only way you can use midpoint is do the diagonals have the same midpoint. If they do have the same midpoint, then you have a parallelogram, because then the diagonals bisect each other. So what shape would these 4 points make? We want to figure out. Look at your distance, midpoints, and slopes. So let's look at the slope. So I label these points A, B, C, and D. And AB has a slope of 2/7. BC has a slope of -7/2. DC is 2/7. AB is 7/-2. So as we see here, we have two pairs of the same slopes. So we know we at least have a parallelogram. Since our slopes are opposite reciprocals of each other, we know we have a rectangle. Then I want to look at the distances to see if I can get any more specific. For the distances, which I'm going to do over here in red, I'm going to take those numbers and I'm going to square them, do Pythagorean theorem. So 2 squared plus 7 squared, 4 plus 49. So AB is a distance of square root of 53. BC, -7 squared plus 2 squared is still 49 plus 4. So that's still the square root of 53. DC, well, it's still 2 squared plus 7 squared, so DC is the square root of 53. And AD is also be square root of 53 because it's negative 7 squared plus 2 squared. So I have all my sides are congruent, and since it's a rhombus and a rectangle, it's also a square. All right, so the set of these 4 points make an isosceles trapezoid. Prove by either using a slope, a distance, or a midpoint method. Well, things we want to know, things we know about trapezoids is we have one pair of opposite sides parallel. So I want to find my slopes. And again, I'm going to name these different letters to make it a little easier to understand. So AB doesn't go up at all, so it has a slope of 0. BC, my slope is I went down 6 over 3, so negative 6 over 3, which is negative 2. CD doesn't go up at all, so my slope of CD is 0. So I have one pair of opposite sides parallel. DA went up 6 over 3, which is a positive 2, so I only have the one pair of opposite sides parallel. So we're good. The isosceles trapezoid, that means that AD has to be congruent to BC. So check your sides. ADs would be 6 squared plus 3 squared, which is the square root of 45. And BC is negative 6 squared plus 3 squared, which is still 36 plus 9, which is the square root of 45. So since we have one pair of opposite sides parallel, and then our legs are congruent, we have our isosceles trapezoid. Number 4, or 34, the 4 sets of these 4 points make a rhombus. So with a rhombus, I know all my sides have to be parallel, or my opposite sides have to be parallel, but all my sides are going to be congruent. So I'm going to look at my slopes first. And again, let's draw in our shape here and label our points. So AB has a slope of 0. BC has a slope of up 4 over 3. DC has a slope of 0. And DA has a slope of up 4 over 3. So we know we have a parallelogram because we have two pairs of opposite sides parallel. So let's check all of our distances. AB is easy to find out because we can just count across. So AB has a distance of 5. DC also has a distance of 5 because, again, we just count straight across. For BC, 4 squared plus 3 squared, that's 5. AD, 3 squared plus 4 squared, that's again 5. So since they're all 5, we have a rhombus. 35, when you add a fourth point in quadrant 3, the shape will be a parallelogram. So since I know I want to look for a parallelogram, I need to add something into this quadrant here. Let's look at my slopes. Up 3 over 3, so this is a slope of 1. Down 3 over 6, this is a slope of negative 1/2. So I need to find a point between, I need to find point D in between A and C so that CD has a slope of 1 and AD has a slope of negative 1/2. Well, let's look. If I do the same thing I did to get from C to get to AB, I go down 3. So there's point D, and let's check if that has a negative 1/2 slope. Down 3 over 6. So point D is negative 1, negative 2. 36, when you add a fourth point in quadrant 1, the shape will be a parallelogram. All right, so 36. We need a fourth point in quadrant 1, so the shape will be a parallelogram. So we know from point A to point B, we went up 4 over 2. So from point D, go up 4 over 2. There's point C. Last question, construct a square inside the circle below. So the first thing we want to do is we want to construct diameter. So the diameter. Then we want to get our compass. Get the compass, there you go. We want to do the perpendicular bisector of this line. So we open it up more than halfway. Draw the arc. Go to the other side of this line. Draw the arc. Next, draw your line. From here, we have our diagonals perpendicular, which makes it the rhombus. And since both lines are diameters, we know our diagonals are congruent. So just connect at each point where your diameters hit your circle, and that's your square. All right, before we finish up, I want to go back to one because I feel like I did not describe it well enough. Number 30. We know to find the distance of a line. So if I'm looking for the x value for m, I know it's congruent to gr. Well, to find the distance, I do x2 minus x1. So I want to find the distance of gr. If x2 is c minus negative a, that equals c plus a. So I know gr has a distance of c plus a. I know the distance of ma has to be the same thing. So I label my points. My question mark is x1, a is x2. I know that a minus x has to equal c plus a. So we subtract the a. Negative x equals c. Divide by negative 1, we get x equals negative c. So that's how we get that point there is negative c, negative b. All right. If you have any other questions, you can ask your teacher. Good luck studying.